Alright, this is your last set of trig notes and your last lesson that you will learn. So, chapter 5, lesson 2 is still on the trig identities that we've been talking about. So if you have your orange piece of paper that has your trig identities on it, it will probably help you and come in handy with this. So, today we're going to look at examples 1, 2, and 4. We're not going to look at example 3. So, the benefit of lesson 2 versus lesson 1. Lesson 1 is really just like simplify this, which can be sometimes confusing because you don't actually know if you simplified it as far as you can. The goal with that is really just like to have a word left, or like in the last example we did, it was like 1 minus cosine, which is still really just one word. So simplifying it as much as you can. So instead of having like 5 things to start with, I'm just left with one actual word. So lesson 2 is on verifying trig identities. So the benefit of this is there's an equal sign, and it's actually already telling you what it's equal to. So you're really just trying, so in this one, in example 1, it says verify that tan squared x plus 1 over 1 minus sine squared x equals secant 4x. The left side of your equation is what we're working with, and I'm really just trying to use my trig identities to actually prove that it's equal to secant 4x. So I already know my answer. So it kind of helps you in a way. I know it's still annoying to use your trig identities to get to that, but at least now you actually know what you're trying to get to and you have an end goal. That does not just mean I get to use random identities and look like I wrote random things on my piece of paper, and then wrote a bunch of things and then wrote secant 4x equals secant 4x at the end. You actually have to use them correctly to make sure you are getting to your answer. So, for this question, your kind of goal that you're going to look at is, the left side is what I'm going to be looking at and working with. Again, you have things that are squared, you have a 1, that should automatically, like for the top and the bottom of this, point to the fact that you are going to use your Pythagorean theorem identities. So on the top, I have tangent squared x plus 1. That is actually one of your identities already. It's written that way. It says tangent squared plus 1 equals secant squared. So I'm going to change the numerator of this to secant squared. So this is coming from here. Then looking at my denominator, I have 1 minus sine squared x. So again, it's squared, there's 1, Pythagorean theorem identity. So your starting identity is sine squared plus cosine squared equals 1. I can rewrite that to cosine squared equals 1 minus sine squared, which is what I have. So I'm going to change my 1 minus sine squared to cosine squared. So again, I'm trying to make this side right here equal secant 4x. So currently, I'm kind of halfway there. I already have a secant to the second over cosine squared x equals secant to the 4th x. Looking at now what you have, my cosine, I'm going to see if there's any way that I can change that to secant. If you look at your reciprocal identities, cosine is the reciprocal of cosecant. So, my reciprocal identity that I'm going to use is that cosine is equal to 1 over cosecant squared x. There are a couple ways you can write that. You could write it out as like actually changing this to 1 over secant squared x. If I have a fraction divided by a fraction, I'm going to just multiply by the reciprocal, which will give me this. You can also really just think about the fact that cosine is the reciprocal of secant. If it's on the bottom and I'm doing a reciprocal identity, it's going to move to the top. So you really could just think of this as cosecant squared x and then moving your cosine squared x to the top, but making it secant squared. Either way is kind of the same process. This one shows your work a little bit more as far as why that's happening. Either way, I'm going to just end up with secant squared x times secant squared x. Whenever you are multiplying, remember you are adding exponents. So I'm just going to end up with secant to the fourth x equals secant to the fourth x, which is what my goal was all along, since that's what I already know my answer actually is. Okay, so this lesson's a little bit easier. Really just using your trig identities, having that orange piece of paper, knowing what to look for. If you have squareds, knowing that it's always going to be a Pythagorean theorem identity. If I have secant or cosine or sine or secant, cosecant, knowing I'm probably going to use a reciprocal. If I have a sine over cosine or cosine over sine, that's when I'm looking at tangent or cotangent, so my quotient identities. So that first, like those first three types of identities are really the ones that we're going to look at for this lesson and that we looked at in lesson 1. All right. So your next one, and for this question, it's written out kind of awkwardly as far as like the multiple choice part. However, again, same kind of thing. It's trying to get you to prove that this is equal to this. There are multiple ways that you can kind of look at that, I guess. The correct answer is D, and to kind of explain that, if you were to like just look at your cosine squared x, and we actually haven't done one where it's replacing it with the number and the letter, but if I leave the 2 where it is, so I'm not messing with the 2, the cosine squared x is the same thing as in looking at your trig identities, cosine squared x is the same thing as 1 minus sine squared x. So if you're just changing that part, that's where this answer is coming from in your problem. So instead of taking like a 1 plus a cosine squared and changing it to just one number, you're taking the one term and changing it to the 1 minus sine squared. So this is still, like from here to here, is still a Pythagorean theorem identity. It's just backwards from what we've done previously, to where I had a 1 plus a cosine and I'm changing it to sine. Now I have a cosine and I'm actually changing it to 1 minus a cosine squared. So that's coming from the fact that that's what my answer is. Like I'm trying to get to 1 plus cosine squared. So I'm actually working backwards and changing to that Pythagorean theorem. So from here, if you were to distribute your minus sign, so this would be 2 minus 1 minus the negative right here would become plus. Then your 2 minus 1 is going to give you 1, and then plus sine squared x. So you're proving, again, that that's what it's equal to. It already tells you your answer. Example 2. Again, also telling you to verify. On this question, it's asking you to do the same thing. Because of the way that it's set up, you're kind of doing the opposite now, meaning, and you can do this either way. You're really just trying to prove that the one side is equal to the other side. Because it's an equation, it really doesn't matter which side. So in the first example that we did, so in example 1, it was easier to deal with my fraction and simplify that to get it to the secant. In this one, I have -2 cotangent x is equal to fractions. I know they're on the right side and the other one was on the left side. It really doesn't matter which way you work with. So I'm really just trying to prove that one side is equal to the other. So I'm going to deal with this side and try to get this side to equal -2 cotangent x, instead of trying to change the -2 cotangent x into a bunch of fractions. So I'm going to take my fractions and simplify them. So again, similar to that, one of the last examples that we did in lesson 1, I unfortunately have fractions that I'm adding together, but if you look at them, your denominators are not the same. So, this side of my fraction, I have a 1 plus cosine x, and then the other side I have a 1 minus cosine x. In order to make them the same, I have to multiply them by each other. So this first fraction, I'm going to multiply by 1 cosine x, and then this fraction, I'm going to multiply by 1 cosine, or 1 plus cosine x, in order to get a common denominator. So whenever I do that, in my numerator, I'm going to have sine times 1 minus cosine x, and again, I'm going to leave it in that format. I'm not going to mess with it. Then I'm going to have 1 minus cosine x times 1 plus cosine x in my denominator. 2 terms times 2 terms mean I need to FOIL that. So when I FOIL, 1 times 1 is going to give me 1. 1 times cosine will give me positive cosine, and then 1 minus cosine is going to give me a negative cosine. So if I have a positive cosine and a negative cosine, they're going to end up canceling out. So I don't have to rewrite that. Then I have a negative cosine times a positive cosine. So negative times a positive will give me negative. A cosine times a cosine will give me a cosine squared. So that's what my new denominator is going to end up being. Then on my other side, I have sine times 1 plus cosine. So again, I'm going to leave it in that format. And then I have 1 minus cosine times 1 plus cosine. So again, I would FOIL. However, I already did that. Same denominator. Would be the same thing. So from here, I now have a common denominator. I'm going to rewrite this as one whole thing over the denominator. So all I'm actually doing is subtracting them, really just writing it as one whole fraction instead of 2 whole fractions. So from here, there are multiple things that you can look at. However, in this one, so your sign, you didn't distribute up front. It's not like in the parentheses, it's a 1 minus cosine. That's not a Pythagorean theorem identity because it's not squared. So in this case, I'm actually going to multiply this sign out and this sign out. So I'm going to end up with sine x minus sine x cosine x. So again, all I'm doing is distributing the sign right here to what's in the parentheses and the sign here to what's in the parentheses. Remember, whenever you do that on this side, the negative in front of the sign is going to go with it. So I would have negative sine x, and then I'm also going to have a negative sine x cosine x. So again, distributed sign to parentheses, this sign, specifically negative sign, to my parentheses. So when I do that, I can combine like terms or cancel stuff out. If I have stuff I can cancel out. So looking in the numerator, I have a sine minus a sine cosine minus a sine minus a sine cosine. This sign is positive and this one is negative, so they would actually cancel each other out. So now I have negative sine cosine minus negative sine cosine. They're the same thing. They're both negative. So because they're both negative, I can't cancel them. However, because they're both negative, I can actually combine them together. So think I have a negative 1 minus a negative 1, or not minus a negative, minus a 1 or plus a negative 1, however you want to think about it. So this would really become negative 2 cosine or sine x. I wrote it backwards. It's really the same thing. 2 sine x cosine x over 1 minus cosine squared x. All right, so continuing through. Looking at your numerator, I'm going to leave my numerator as is for 8 the second. There's nothing else that I can cancel. Your denominator, the 1 minus cosine squared x. At this point, you should know that a 1 and a number with a squared in it is probably going to be a Pythagorean theorem identity, which it is. 1 minus cosine squared x is the same thing as sine squared x. So I would have negative 2 sine x cosine x over sine squared x. When I do this, I have a sine in the numerator and 2 sines in the denominator. So this sine is going to go away completely, and this will just become 1 sine. Sorry, running out of space. So now I have negative 2 cosine x over sine x. If you look back to what we were trying to get to, I'm trying to get to negative 2 cotangent x. I have the negative 2 in my problem. So if I have cosine x over sine x, and I need that to become cotangent, cosine over sine is one of your quotient identities. So your quotient identity is that cotangent is equal to cosine over sine, which is what I have. So I would change this to negative 2 cotangent x, which is my answer, kind of what I was trying to get back to. Okay, so a lot of work, really just proving one side's equal to the other side, plugging in, rearranging. It's helpful to actually now know what your answer is going to be. So, looking at example 4, so we're not doing example 3. So looking at example 4, again, same thing. You are verifying that cosine x times secant squared x times tangent x minus cosine x times tangent cubed x is equal to sine x. So basically all of this I need to prove is just equal to sine. There are right and wrong ways to get to an answer. However, like, there are easier ways and there are harder ways. There are multiple ways that you could start on this one. You could change your like secant and tangents to sines and cosines. That's completely up to you. If you get stuck and you don't know what to do, that's a good starting point. However, on this question, where I would start is to actually factor. And part of that comes from like by factoring. If you have something that's really long, and they both have some of the same stuff in them, I would look to see if there's something you can factor out. So, my first 3 terms have a cosine, a secant, and a tangent. My second terms have a cosine and a tangent. So there's at least a cosine that I can factor out, and then they both have at least one tangent that I can factor out. So when I do that, cosine times tangent to get me back to this first one would just be secant squared x. Then for my second one, I have cosine tangent times what is going to get me back to cosine tangent squared. I already have a cosine, so it would just be a tangent squared, because I need to end up with a tangent cubed. Okay. Ignore that that's very bad parentheses, but y'all know what it is. Okay, so from here, your cosine tangent is going to say cosine tangent for a second. What is inside of your parentheses that you factored? Both have a square in them. If it's squared, you're going to look at your Pythagorean theorem identities. So one of your Pythagorean theorem identities uses secant and tangent. So it's the one that says tangent squared plus 1 is equal to secant. You can rewrite that as secant squared minus tangent squared is equal to 1. So I am changing the inside of my parentheses to a 1 because of my Pythagorean theorem identities. From here, I need this whole thing to just equal one sine by itself. I currently have a cosine and a tangent. Your next step, and again, it's always a good idea if you have stuff that is not sine or cosine to change it to a sine or a cosine. So my cosine, I'm going to leave as is. My tangent, I'm going to change. So I'm going to change this by looking at my quotient identities. So one of my quotient identities is that tangent is equal to sine over cosine. So I am going to replace my tangent value with sine over cosine. When I do that, I have cosine times sine over cosine. If you were to actually multiply out, you can multiply and then cancel. However, you can cross cancel and then just end up with sine x, which is what I'm trying to get to. So a little bit of an easier one. I know it looks harder, but less steps to get to your answer. So that is examples 1, 2, and 4.